Dear students, for today we'll see what do we mean by vestigial sideband transmission. Now here we are going to see how a video signal is transmitted in TV transmission. Now when we transmit a video signal in a TV transmission, the video part of it is amplitude modulated and the sound part of it is frequency modulated. So here we are going to see today the video part, which is amplitude modulated, and in that, what is vestigial sideband transmission. So here our topic will be vestigial sideband transmission, which is in short called as VSB transmission. So here if you see a simple block diagram of modulating signal and a carrier input to a product modulator. Okay. So here you can see you're having a modulating signal. Say this is your information wave. This is a low frequency information wave. Okay. And this is your high frequency carrier, which will be modulated, amplitude modulated. Now this carrier will be amplitude modulated with respect to the instantaneous value of the modulating signal. Okay, so here you will get your amplitude modulated wave. Okay, now amplitude modulated wave, what you get here will be double sideband. Will be double sideband. That means if you see the spectrum, okay, if you see the spectrum, frequency spectrum for double sideband, okay, say this is your carrier frequency. So you can see something like this, where this point will be carrier frequency plus modulating frequency, and this point will be carrier frequency minus modulating frequency. So this will be your lower sideband and this will be your upper sideband. Okay, so this is your double sideband. Now the information sent in a double sideband is same in each sideband. Say whatever information you are having in lower sideband, that same information you will be having in upper sideband also. That means by sending double sideband, by or transmitting double sideband, we will be sending the same information twice. Okay. Now from this, if you come to a single sideband transmission, if you filter out one sideband and if you pass only one sideband, say upper sideband, okay, then this is your FC, this is your FC plus FM, and this is your single sideband technique. Single sideband technique. Now in this, we can send this and save our bandwidth. But while sending this, at this lower frequencies here, we should have a sharp cutoff filter. That filter should sharply cut off the correct upper sideband and pass it. So when we are cutting here, we might not get a steep slope. We might get something like this, something like this. So it is not easy to realize a practical filter which can send a single sideband information. Okay. Now here, why this is important, because in TV transmission, the information at the lower frequencies will be very important, and therefore what we have to take care is of the frequencies which are just near around carrier frequency. This frequency is just to take care. So to okay, so to avoid a filtering action which might lose information, so to avoid that, we will have a filter which will filter out, okay, filter which will filter out a complete sideband, that is upper sideband, say. And because we want to save this lower frequencies, we will pass a replica of the next sideband. Say if this was your lower sideband, then we will take a part of it. So this part will be called as vestige. This part will be called as vestige. Now, a complete sideband along with a part of another sideband will be sent. So that is your vestigial sideband. Now, in this, you're not sending double sideband. You're sending only single sideband, but a part of another sideband, which is called as vestige. So it is this type of or transmission is called as vestigial sideband transmission. Okay, so that type of filtering you can do here and get here what you see as vestigial sideband signal. Okay, so with this we are saving the bandwidth, we are saving the information at the lower frequencies, and afterwards when we reach at the receiver we can eliminate the lower frequency information which is a doubling on both the side, upper sideband and lower sideband. Okay, that can be taken care, but the information should be sent correctly. Okay, so the lower frequencies are taken care and sent to the or transmitting. So if you see the complete block diagram here, so you can see modulating signal at the beginning. So this is your information wave. Okay, this is your information wave or low frequency. Okay, so this is your carrier, a high frequency. Okay, now this is going to do amplitude modulation, and here you will get a double sideband suppressed carrier at the output. Okay, from that double sideband, whatever you are having, say this is your double sideband spectrum where you are having upper sideband and lower sideband. From this, if we transmit only the upper sideband and a part of lower sideband, okay, part of lower sideband, then it will be called as vestigial sideband. So this is upper sideband and a part of lower sideband. Okay, so this will be called as a vestigial sideband VSB signal, and that will be amplified linearly and power amplified, and then it is sent to the transmitting antenna. Okay, now here you are saving the bandwidth and you're saving the information of the lower frequencies also. Okay, so this is how a vestigial sideband is taken care. Means a vestigial sideband is taking care of the lower frequencies, and this vestigial sideband transmission in amplitude modulation is used to transmit video signal. Only video signal is going to go through vestigial sideband. Okay, whereas the sound signal will follow frequency modulation. Okay, so here, if you see the or description in the video signal, very low frequency modulating components, that is the components which are near to your carrier. Say if this is your double sideband, if this is your double sideband, then this is your center frequency, and here you are having FC plus FM, and here you are having your FC minus FM. So this is lower sideband, this is upper sideband. Okay, so the frequency which is here in this area, okay, here, here, and here, these lower frequencies are very important and they exist along with the rest of the signal. These components give rise to sidebands where close to the carrier frequency, which are difficult to remove by physically realizable filters. The low video frequencies contain the most important information of the picture, and any effort to completely suppress the lower sideband would result in objectionable phase distortion. Okay, so if you want to send only one sideband, then it will miss out the lower frequencies, and which will be an objectionable phase distortion. This distortion will be seen by the eye of human being as smear in the reproduced picture. Therefore, as a compromise, only a part of the lower sideband is suppressed, and the radiated signal then consists of a full upper sideband together with carrier and the vestige, that is the remaining part of the lower sideband. Okay, so that is called as vestigial sideband. So this pattern of transmission of the modulated signal is known as vestigial sideband. In the 625 line system, frequencies up to 0.75 megahertz in the lower sideband are fully radiated. Okay, up till if you see till the end, it will be 1.25 megahertz, but 0.75 megahertz will be fully radiated. The picture signal is seen to occupy a bandwidth of 6.75 megahertz instead of 11 megahertz. That means what we are speaking here is, say if you were transmitting double sideband, okay, double sideband. Say this is our FC, okay. Now this will be around 5.5 megahertz, and this will be also around 5.5 megahertz, okay. So this is FC minus 5.5 megahertz, and this is FC plus 5.5 megahertz. So this 5.5 and this 5.5 total, if you transmit double sideband suppressed carrier, okay, you are transmitting 5.5 plus 5.5 is 11 megahertz, which is of no use because whatever information you are having in lower sideband, that same information you will be having in upper sideband. So what we want to do is we want to send a single sideband. But while sending single sideband, there is a problem of filtering exactly at the zero, okay, at the carrier rate here. So that is why with a practical filter, we will take a part of another sideband, and this much we are going to transmit, and that will be called as vestigial sideband, and that will occupy a bandwidth of 6.75 megahertz instead of 11 megahertz. So you're saving the bandwidth. So if you see the signal here, vestigial sideband signal, as we transmit. So here you can see you are having your zero, which will be your suppressed carrier. Okay. So here you will be having your zero, which is your suppressed carrier here. So here you can see this part is your carrier frequency. Okay. And from this part, you see that this is your upper sideband. This is your upper sideband. Okay, full upper sideband. This is full upper sideband. You are going to transmit. Okay, the full upper sideband till here you can see. Okay, so here you can see this has 5.5 megahertz here. Okay, and then because I want to save the dropping off or the losing of this lower frequency part, I will use a part of the next sideband so that I can realize a practical filter for it. So I will use even this part, a part of the lower sideband. Okay, this is your 0.75 megahertz. And if you see this rolling off till the filtering action, it will be 1.25 megahertz. Okay, so this 5.5 megahertz, okay, on the upper sideband, whatever you are having, and the lower sideband 1.25 megahertz. Okay, so totally it will come to around 6.75 megahertz. Okay, so that is what we are going to send. That is from here till here is the bandwidth for the video signal. Video signal in TV transmission. Okay, in TV transmission. Okay. Now here then after that you will be having your sound carrier, and there will be a guard band of 0.25 megahertz, and then till here you can see 5.75 megahertz. Okay. Now this will be the total channel width. If you see the total channel width, what we are going to send in vestigial sideband, here you can see it is 7 megahertz. Okay, so out of 11 megahertz you're sending 7 megahertz. This is your picture carrier here. Okay, and this is your sound carrier here. So here you can see your sound carrier. Okay, so sound, then afterwards we can use frequency modulation for the sound signal, which will take care in the next little bandwidth. But here the video signal is going to follow a complete sideband. This is the full sideband and a part of another sideband, lower sideband. So this is called as your vestigial sideband transmission for video transmission in TV transmission. Okay. Now, very clearly, in a TV transmission, video signal will be modulated using amplitude modulation. In that, we are not using double sideband suppressed carrier. We are not using double sideband full carrier. We are not using single sideband, but we are using a single sideband plus a part of another sideband. So it is called as vestigial sideband. Okay, and that we are using to uh, transmit video information, and the sound will be taking care with the help of frequency modulation. Okay, because there the volume is directly related to the amplitude, so we cannot go with amplitude modulation for sound. So for sound we use frequency modulation. Okay, but as far as the video signal is concerned, we are using vestigial sideband transmission, which means a complete upper sideband plus a part, a vestige of the lower sideband. Okay. Then if you go to see the advantages of vestigial sideband, the main advantage of VSB modulation is the reduction in bandwidth, what we saw from 11 megahertz to 7 megahertz. It is almost efficient at the SSB single sideband. Due to allowance of transmitting a part of lower sideband, the constraint on the filter have been relaxed. So you can use a practical filter and there is no risk of losing the information of lower frequencies. So, practically easy to design filters can be used. It possesses good phase characteristics and makes the transmission of low frequency components possible. Then if you go to see the application, the main application here will be VSB is used. VSB modulation is used for video signal transmission in TV. Okay. So here if you see, VSB modulation has become standard for the transmission of television signal because the video signal needs a large transmission bandwidth if it is transmitted using double sideband full carrier or double sideband suppressed carrier techniques. So instead of sending double sideband, we will send one sideband fully and a part of another sideband so that the lower frequency signals are taken care, and that type of modulation is called as vestigial sideband. Okay, thank you, students.